Okay, so hello, this is WPP number 9, which is Concepts 4 through 8, Unit L. Okay, so Part A says, Nora is throwing a party to celebrate her business success. She is inviting her employees and important business people. She has to select one of 5 main course dishes, one of 3 dessert courses, and one of 7 beverages. How many different meal courses are possible? Okay, so we're going to be using the fundamental counting principle. So we're just going to multiply the different possibilities that we have. So we have 5 main dish courses. We have 3 dessert courses and 7 beverages. So the total number of possibilities is 105 different meal courses. And that's our answer for Part A. Part B. It says, Nora has decided to make the party even bigger and now wants to add decorations. She goes to a flower shop to see different flower arrangements. She is asked to select 5 different flowers to put into a mixed arrangement. From a selection of 20 different flowers, how many ways can Nora select the flowers? So for this part, we're going to be using combinations, which is NCR. So we're going to find the total number of flowers that we have to pick from is 20. And the number of flowers that she wants is 5. So it's 20C5. And when we plug it into the calculator and calculate it, we get 15,504. So that is how many ways Nora can select the flower. So that's our answer for Part B. Part C says, Nora finds organizing the party too stressing, so she decides to make a party committee consisting of 7 members. She wants 1 decorator, 2 invitation planners, 3 people to set up, and 1 person in charge of the food. There are 5 decorators, 7 invitation planners, 13 people to set up, and 3 runners to be in charge of the food. Nora wants to know how many 7-member committees are possible. So this is similar to Part B, only this time we have multiple events. So what we're going to do is go over each of the events separately and then multiply them together at the end. So the first one is 1 decorator, and the total number of decorators to choose from are 5. So it's 5C, and since we want 1, it's 1. And then we're going to multiply that by she wants 2 invitation planners, and there's a total of 7 invitation planners, so it's 7C2. And then 13 people to set up, but she wants 3, so it's 13C3 times there's 3 people who want to be in charge of the food, but she only needs 1, so it's 3C1. So now we're going to multiply all of these together, and when we do so, we're going to get 90,090 possibilities that Nora can have for the 7-member committee. And that's our answer for Part C. Part D. During the party, Nora will be making a ceremony to honor her most hardworking employees. Nora has 11 employees total. In how many different ways can her employees come in first, second, and third? Okay, so for this problem, we're going to be using permutation, which is NPR. And the reason we're using NPR this time instead of NCR is because this time the order matters in the way that Nora chooses her employees, since they are running in first, second, and third. So like NCR, N is still the total number, and R is how many she wants. So the total number of employees is 11, and she's going to select 3 out of those 11 to run in first, second, and third. Okay, so it's going to be 11P3. So now we plug that into our calculator and solve, and we should get 990 different ways that her employees can come in first, second, and third. And that's the answer for Part D. Part E. After a long week of party planning, Nora comes to a day to relax. While sitting for a long time, Nora becomes curious in how many different words she can make using her favorite word. Nora wants to know how many permutations there are for the letters in the word planning. For permutations, we're going to use the total number. We're going to take the number of letters and its factorial and divide it by each of the repetitions that there are. So first, let's count the total number of letters there are. So there's 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 letters in total. So we're going to take its factorial. Now we're going to find from this word how many letters are repeated. So we have P, L, A, N, another N, I, N, G. So we only have one letter that is repeated 3 times. So it's going to be over 3I since that's the repetition. And now all we have to do is plug this into the calculator, and 8I is 40,320 over 3I, which is 6. So once we solve, we divide, and the total number is 6,720. And that's our answer for part E. Okay, thanks for watching.